Hello guys, welcome back to the channel. So today's LeetCode problem 1722, minimize Hamming distance after swap operations. It has been asked in Google. It is a medium level question. So till the end of this video, what we are going to cover is what pattern this particular question falls in, and how to recognize this pattern and how to use this pattern in various questions. Okay, so before moving forward in this video, there are some prerequisites for this question. So you guys must know some basic graph knowledge, what are connected components, and the knowledge about disjoint set. So I have added few links in the description. You can go through those links to get the knowledge regarding this. So let's go through this problem statement. So we have been given source array and a target array, and the lengths of both are equal, and allowed swap array. And what we need to do is calculate a Hamming distance. So what is the definition of this Hamming distance? So it is given as we need to calculate a total positions where the elements at source and target differ at a particular position. For example, 1 and 2 here differ at 0th position, so they will contribute 1 to the Hamming distance. Similarly, 2 and 1 is differing, so they will contribute 1. 3 4 is differing, they will contribute 1. 4 5 is differing, they will contribute 1. So the total Hamming distance is 4. Now what is the use of this allowed swap? So we have been given a pair 0 1 2 3. So it means we can swap 0th and first position elements in the source array. So it can be 2 1. We can swap this any number of times, and 2 comma 3 can also be swapped. So 3 and 4 can be swapped. So what we need to do with this is we need to change the source array, swap any number of times, do whatever operations we need to do, and using the swaps, and calculate the minimum Hamming distance. So I have just swapped the elements, so it will become 2 1 4 3. So now if we calculate the Hamming distance, these two elements are equal, so they will contribute 0. These two are equal 0, these two are equal 0, these two are differing, so 1. So the minimum Hamming distance here is coming as 1. Okay, the naive approach can be use all the permutation of this allowed swaps on the source array, get all the permutations of the array, and then using the target calculate the minimum Hamming distance. But the problem is calculation of this all this permutation will take a lot of time, and your solution will get an exponential time complexity, and this is bad. You can't tell this in an interview. Okay, let's take this example. In this example, the allowed swap is given as 0 1 and 1 2. So 0 and 1 can be swapped, and 1 and 2 can be swapped. But do you think 0 and 2 can be swapped within each other? The answer is yes, because this basically creates a group 0 1 2. Now within this index we can use any way to like swap elements between these three indexes. So how this helps us? So we can consider this example. At 0th position we have 1, at 1th position we have 2, and second position we have 3. Now 0 1 2 have formed a group together, and in the target array we have 2 3 1 2 3 1. Now using this group we can like change the position in the way which we want to. Like 2 can be swapped to either here, 1 can be taken here, and 3 can be taken here. So the final will be 2 3 1. Now if we calculate this Hamming distance, this will not contribute anything, this will not contribute anything, this will not contribute anything, this will not contribute anything. So the Hamming distance will be 0. So if you see, the initial Hamming distance was 3 because all the elements were differing. But because of this grouping, we have minimized this Hamming distance. Okay, so let's think of this as a graph. Every index in this allowed swap array as nodes, and each allowed swap as an edge. So this creates two connected components, and we have seen like we have created groups, right? And the swap was possible within those groups only. So here also the swap is possible within connected components only. Now how DSU helps us? So when you are creating a connected component, DSU helps you create that in order of n time. You can do this with BFS, DFS also, but this problem specifically says it's a DSU problem. So one tip is that whenever you see the connect graphs through swap, edge, or roads, or etc., basically when you are creating a connected component from a problem, think of it as a DSU problem. Okay, so let's go through the algorithm for solving this problem. The first step will be just use DSU to calculate the connected components. So we are just calculating the connected components in the first step. The second step will be we will have to create a group of the elements. So using DSU we can create a group. So we can see from this connected component 0 and 1 are creating a group and 2 and 3 are creating a group. So what this group means is that swaps are only possible within these groups. The third step will be to collect the source and target values at a particular group. So what values at 0, 1 and what values are the second group 2 and 3. The fourth step will be to match these values. So I will take this example. So in the group first 0 and 1, the source values are 1, 2 and the target values are 2, 1. But we know that within a group any number of swaps are available in any order. So it just boils down to if the frequency of both the elements are equal. If like here you can see 2 is appearing one time here, 2 is appearing one time here, 1 is appearing one time here, 1 is appearing one time here. So the for this the Hamming distance will be 0. Similarly in this case 3, 4, 4, 5. You can see 4 is appearing one time in the both, but 3 is not matching anything. So frequency of 3 is 1 and frequency of 5 is 1. These two guys are differing. So they will contribute 1 to the Hamming distance. Okay, so let's try run this complete code. For DSU code, I have given that in the description. So let's go in a step-by-step way. So first, as we discussed, we will be creating the disjoint set. So the from the allowed swaps, so it will look like this. The connected components. So you can see here we are doing the same thing, creating the disjoint set, creating a new data structure of disjoint set, and using the union operation, we'll be able to get this connected component. In the second step, what we have discussed to do is group similar swapping indexes. So what we have done is we have created a map of where the key is integer and the value is list of integer, where the list of indexes which will have the same where the swaps are allowed. So from this disjoint set only we are creating this. So 0 and 1 will be in one list and 2 and 3 will be in one list. 0, 2, 2, 3. We are just adding those things here. You can go through this code. The third step what we are doing is mapping things. So like what we will do is go through each group, check for what all source elements are there. Then we are just creating a frequency map. Okay, so this frequency map is just storing the number of elements, the number they are appearing. Okay, so at the end we are just so you can see here we have created the frequency map. We are just putting things inside the map according to the times they are appearing. So at the end what we are just doing is we are just comparing with the target values. Okay, so target at 0, we are comparing if it's present in the frequency map. If it's present in the frequency map, we can just nullify it, like this will not contribute in our distance. Okay, so if it's not present, then only it will contribute in our distance. So you can see in the second case where the source was 3 and 4, so frequency was 3 was 1, frequency of 4 was 1, and when we are iterating the target values, okay, so here the 4 will get nullified, but when we go through 5, we check if the map dot contains target 5, but the map will not contain target 5. So we are just increasing the result. So this result shows the Hamming distance. Okay, so at the end we are just returning this result. Okay, let's discuss the time complexity. So in the first step we are creating the DSU. So it will be order of n operation. The grouping is also order of n operation, and in the last step we are just matching the elements. It is also an order of n operations. So it comes to be order of 3n, but eventually it's order of n solution only. The space complexity, for the DSU we are creating the order of n space. For grouping we are using a map. It will take order of n space in the worst time. And for the frequency calculation, a map in the worst case will take order of n space. So it is total order of 3n, but it's only order of n only. Okay, so recap from this problem. When you see the grouping of elements, just think that DSU can be applied here for finding the connected components. So that's it for this problem. If you are in the same journey of interview preparation, you want the content on LeetCode, LLD, HLD or GenAI, please follow along. The code will be given in the description. Thanks.